Today we are learning about linear equations in real-world applications, also known as story problems. So our learning target today is that we will be able to write an equation for the relationship between values given in a verbal description. So before we start with the actual real-world application problems, let's take a look at some of the important operations and words that we want to be able to recognize as representing those operations when we are working in a word problem. So addition, we will obviously know when we hear the word add. When we read the word add, that is addition. Sum also means addition. Plus, more than, and. So like if I said 2 and 2 is 4, so and also means add, and then increased by. Okay, and there could be others as well, depending on the scenario. All right, subtraction. Obviously, subtract. Okay, difference. Minus. Less than. And decreased by. Okay, when we are looking at multiplication, words that represent multiplication are times, product, twice, specifically for 2 times, multiply, and of. And that of is typically used when you have a portion of something. So like if I said half of 5 is 10, of means multiply. But typically, again, that is used when we have a fraction involved, when you're taking a portion of something or a part of something. So division, divide, or divided by. Quotient. Into. So like 2 goes into 5, or 2 goes into 10 5 times. And then that would be, when you do it that way, when we see the word into, the order is somewhat reversed around. So if I said 2 goes into 10 5 times, the division problem would be 10 divided by 2. So just anytime you see those words and you're not sure, remember to take a smaller problem with numbers that you do understand, like the 2, the 10, and the 5, and then so you can get that appropriate order, and then use that appropriate order with your real numbers from the problem. And then out of. Out of is typically used when we have a fraction. So example, I'm going to give an example for that one. So when you say 3 out of 4 dentists recommend Crest, that would be 3 divided by 4, which is 0.75, or 75% of dentists would recommend Crest. So equal, we use the word is for equals. So if you had 2 plus 3 is 5, we know that that is means equals. Equal to. Okay, you may or may not have the word to in there. And then total or totals. Okay. So like you might say the number of apples and oranges totals 10. So A plus O equals 10. All right, so those are just some cue words that you want to know what they are equal to when you are writing a word problem and trying to represent a word problem with an equation. So sometimes you'll hear your math teachers use the word translate. And if you think of it, really math is a language that represents, numerical representation of things that are happening in our everyday world. So I would say that's a pretty good choice of words. So you're taking a real world application and you're representing that with a mathematical equation or statement. So definitely translating would be a good match when describing that situation. So translate the following word problems into equation. The sum of 6 and some number is equal to 20. So when we see the word sum, we know we're adding. So 6 is obviously the number 6. Some number, we don't know what that is, so we can call that x or n, is equal to, and then 20. Okay, so the sum of 6 and some number is equal to 20. We would write that as 6 plus x equals 20. The sum of 6 plus some number is equal to 20. So that is the expression, that is the equation to represent this scenario. Number 2, the difference between the length and width is 5. So you have to be very specific when we're looking at division and subtraction because order matters. So when we have the difference, we know we're looking at subtraction, and then length will also represent that with L. And in math, we don't like to use a print L to represent the letter L because it looks like a number 1. So we'll always see the manuscript or cursive type of L when we're using the letter L in algebra. So the difference between the length and the width is 5. So that means equal, and 5 is obviously 5. So again, we're going to use that manuscript or cursive L. So the difference tells us that we're subtracting between length and width is 5. So we would say L minus W equals 5. Number 3, 10 more than 3 times x is equal to 9. So when we have multiple steps here, which this one we do have multiple step equation, or 2-step equation at least, we want to be very careful and ask ourselves some questions as we go. So 10 more than what? 10 more than 3 times x. So it's not 10 more than 3, it's not 10 more than x, it's 10 more than 3x. Okay, so this 3 times x is represented as 3x. And then, so 10 more than 3x is equal to 9. And we need to be very specific with the order, even though in addition, we can switch around order without changing the answer. We want to get in the habit of writing this in the order that is indicated, so that when we're working with subtraction and division, we don't fall into this pattern of I can write it in any order that I want. So we're going to be very intentional, even when we're doing addition and multiplication, to follow the order described, so that when we do it with division and subtraction, we don't make mistakes. So in order to say 10 more than something, you have to have that something that you're starting with. So the number that we're starting with is 3x, all right? So 10 more than 3 times x, in order to have 10 more than something, you have that starting point. So we would say 3x, and then 10 more than that is equal to 9. I would not mark it wrong if you wrote 10 plus 3x. Addition is commutative. I can write those in either order, 10 plus 3x or 3x plus 10. But again, this is the preferred answer. We want to get into the habit of understanding that this would be first, and then you would increase it by 10. All right. So number 4, the total number of adult tickets and student tickets sold is 800. So the total, when we see that word, it tells us that we're adding. So the total number of adult tickets we'll call A, and student tickets we'll call S. And I prefer to use a cursive S instead of print S, because sometimes the print S might look like a 5. So the total number of adult tickets and student tickets sold is, remember, is means equals 800. So here we have addition. I'll write these below so they're not in problem number 3 there. So adult tickets plus student tickets, so is total of 800 tickets sold. All right, so adult tickets plus student tickets equals 800. Number 5, the length of the rectangle is 3 more than twice the width. Great. Okay, so this doesn't have an equal sign in it. It's just an expression. Oh, we do have the is. Sorry, we do have it. So the length is 3 more than twice the width. So we have 3 more than, so something is being increased by 3 because 3 more than something. 3 more than what? Twice the width. So the length of the rectangle is, this will be L equals 3 more than what? Well, 3 more than twice the width. So we'll start off with twice the width and we'll increase that by 3. So 2W plus 3. Number 6, 8 is 3 less than 5 times n. So here we have 8 is 3 less than. So in order to have 3 less than something, we have to find out what we have to start with and then take away 3. Okay, oh, take away is another word we did not use for subtraction. So let's add that in. To our notes as well, take away. And then, so 8 is 3 less than 5 times m. So you have to ask yourself 3 less than what? Well, it's not 3 less than 5, it's not 3 less than m, it's 3 less than 5 times m, so it's 3 less than 5m. So this equation, all right, will be 8 equals, so when we have that less than, this reverses our order, okay? So 8 is 3 less than 5 times m. We start off with the 5 times m and then subtract 3. And if you're ever confused with this and you're not sure if your order is correct, put in real numbers that you can obviously know what is correct or not. So if I just said 8 is 3, I'll use real numbers too, so it's even more obvious. So if I said 8 is 3 less than 11, we would know how to write that. 8 is 3 less than 11. I would write that as 11, or excuse me, 8 equals 11 minus 3. 8 is 3 less than 11. 8 equals 11 minus 3. So if you're ever confused about the order, ignore the variables for a moment, put in very simple numbers that you do know. 8 is 3 less than 11 will be written as 8 is equal to 11 minus 3. That gives us a mathematically correct statement. And then follow that same order in your actual word problem. And that will be just a little helpful tool. This strategy is called Make It Simpler. Okay, so we're just kind of making a little smaller, easier, similar problem that we do understand what to do with, and then we follow that same order in our problem that's a little more complex. Okay, so that strategy is called Make It Simpler. Number 7, -7 times x divided by 3 is equal to 15. So this one is a little bit vague, so we have to be really careful. So we have -7 times x divided by 3. So x divided by 3, this one to me is a little vague. I'm just going to peek at, yeah. So -7 times x. Let's add in the word all right here, all divided by 3. Okay, so -7 times x. This gets divided by 3. So over 3 is equal to 15, equals 15. Okay, so that we're just going to clarify that -7x all divided by 3. So or both, we wouldn't say both, but we would say all. So that just to clarify that, we're putting in the word all right here, because otherwise it's a little confusing whether it's -7 times x over 3. Okay, and actually it doesn't matter. They'll work out equivalently anyway. So we didn't need to add in that all. The product of 3 and x is 20. Okay, so product tells us that we are multiplying. So we're multiplying 3 by x, and we get a product of 20. So 20. 3x equals 20. I'll write that a little neater just below. Number 9, 8 times the sum of a number and 15 is 48. So this one we have to read really careful. It's not 8 times n or 8 times 15, it's 8 times the sum. So first we need to get the sum, and then we increase that by, or multiply that by 8. Okay, so here's our sum, a number and 15. We would write that as n plus 15. And then it's 8 times that sum. So in order to tell the reader of our problem that they have to find the sum first and then multiply the sum times 8, we need the parentheses because we know that in the order of operations, PEMDAS, okay, the parentheses have to be done first. So if we want the sum to be multiplied by 8, we need to indicate that in our problem by putting the parentheses around n plus 15 so that the reader knows find the sum first. And then once you have the sum, multiply that times 8. Okay, and then is 48 equals 48. Number 10, you want to change your cell phone service. You want the new iPhone. Verizon is offering the phone for $210 if you sign a contract. To get unlimited talk and data, it will cost $59 per month. Write an equation to represent the total cost C of your contract as a function of time T. Okay, so here we have the initial amount, $210 to buy the phone, and then $59 per month. And T is representing time, the number of months. So we would say our total cost, C, is equal to our initial amount, $210, plus $59 per month, so 59. And they told us typically I would use M for month, but they're giving us specific directions to use T for time. So C is equal to 210 plus 59 T. And then when we're writing a T in algebra, we like to use the manuscript T because a print T would look like a plus sign. Okay, so then also, we already know this from slope-intercept form, but we want to have our constant last. So this is, remember y equals mx plus b. Well, we would want to have our constant last because that helps us to remember, first of all, that's just the order that we write things in algebra. But it also helps us to make the connection between this form and slope-intercept form. So when we're graphing it, 59 would be our slope and 210 would be our y-intercept. So we want to keep our good habit of writing our variable first and then our constant last. Okay, so cost would be equal to $59 per month plus $210 for the phone. And that's a one-time fee or the starting amount. If you want to sign a contract for 2 years when you buy this phone, how much will it cost you? Okay, so 2 years would be 24 months. So let T equal 24, and then we evaluate. So our cost will be equal to $59 per month times 24 months. So $59 per month times 24 months plus the $210 for our phone. So our cost is equal to there we go. Let's see if we can turn on the light here. 59 times 24 plus 210. And we will get $1,626. So for 24 months of the cell phone service plus the cell phone itself would be $1,626. Part C, if you spend $2,334, how many months did you sign a contract for? So here they're giving us the total cost and asking us to find the number of months, T. All right, so we have our initial equation right here. Cost is equal to $59 per month plus the $210 for the phone. So we're going to substitute, I'm going to just write this down here for us. The cost is equal to $59 per month plus $210. And then they told us that our total cost was $2,334. So we know that the monthly fee is $59 and the initial cost of the phone was $210. So we can calculate the number of months by solving this equation for T. So we would use our order of operations in reverse. And divide by 59. Remember, 59 divided by 59 is 1, so we get 1t is equal to then 2,124 divided by 59 would be 36. So we signed a 36-month contract. And then we know that T was in terms of months, so we would know this is a 3-year contract. Okay, so I signed a 3-year contract. Okay, the next page. So next we're going to talk about standard form of a line. We've already worked with slope-intercept form of a line and point slope form of a line. So today we're looking at standard form of a line. So a standard form of a line is ax plus by equals c. So x is the same x that we've been working with. Okay, it is really important to notice or to make note that now when we had slope-intercept form y equals mx plus b, we had m, which was our slope. A is not our slope. A is just part of our story problem. It's some variable, some number in the story, okay? This capital B is not our lowercase b. It is not the y-intercept, okay? So we're going to just make a note of this. So standard form of a line is ax plus by equals c. And then we're just going to write some facts about standard form of a line. Number one, standard form of a line is useful in a story problem that involves a total. So like a part plus a part equals a whole. So that's really useful, a really useful form of a line when we're working with story problems that involve a total, okay? So standard form of a linear equation is useful for word problems that involve a total. Okay. We have not looked at graphing from standard form yet, but when we do, we will use the x and y intercepts to help us to graph. Okay, so most easily graphed by finding the x and y intercept form, or excuse me, the x and y intercepts, most easily graphed by finding the x and y intercepts. And then they do not tell us slope or y-intercept. Okay, so the b is not equal to the lowercase b. This is not the same b from slope-intercept form. It is not the y-intercept of our line. Okay, does not show slope or y-intercept. Okay, and I'm just explicitly writing that out because that's a common misconception. Okay, so this B is, this capital letter B is not the same as our lowercase letter b. And so standard form of a line is typically part plus a part equals a whole. All right, so let's look at some examples. We're not solving these problems, we are just writing the equation. So we're just learning how to, we already know how to solve equations. So right now we're just learning how to take a story problem and put it into a linear equation, specifically standard form of a line. So number 3, you and your friend go shopping for shoes at a store. Currently, they have a sale for sandals that are $19.95 and dress shoes that are $50. You and your friend spend a total of $179.80. Okay, so sandals plus dress shoes equals total. So that's kind of our verbal model. Sandals plus dress shoes equals total. Okay, so here's our AX plus BY equals C. Okay, so let's just, for consistency's sake, when we're working on these problems, the first thing that is mentioned when they're adding them, let's use that as the first variable. So 1995 S plus 50 D is equal to 179.80. And we don't put the dollar sign in the equation itself when we're giving a verbal answer. Once we solve it, then we would. Okay, so right now, again, we're just concentrating on how would we write this as a linear equation. Number 4, Fredo makes good pizza. He sells rounds and squares. The squares sell for $12 each and the rounds sell for $15 each. On one Sunday, he takes in $390. Write an equation in standard form to represent the situation. So rounds plus squares equals our total. Okay, so round pizzas plus square pizzas equals our total. Oops, I'm just going to actually, I'm not boxing that in because that's not the answer. So that would be our equation as a verbal model. So round pizzas were, oh, sorry, I did rounds plus squares because they mentioned that first here, but the round pizzas were $15 each and squares were $12 each. So 15R plus 12S equals $390. And then just so you are looking forward, we're not graphing today, but when we do graph, you would decide which variable would go on your x-axis and which would go on your y-axis. This is not a dependent independent variable situation, so we don't have an explicit need to have the independent variable be x and the dependent variable be y. So we really could graph either of these on either axis when we have a story problem where you have something like round pizzas versus square pizzas. Number 5, your school is sponsoring a pancake dinner to raise money for a field trip. You estimate that 200 adults and 250 children will attend. Let X represent the cost of an adult's ticket. So here's our key. And let Y represent the cost of a child's ticket. Okay. All right, and so then we want to write an equation in standard form that will tell how much to charge for each ticket in order to raise $3,800. So adult tickets plus children's tickets would give us a total of $3,800. So adult ticket cost total. So we'll call it sales because the total sales would be the number of tickets multiplied by the individual ticket price. So adult ticket sales plus child ticket sales equals total sales. And these are all in dollars. So then we want to write our expression, or excuse me, write our equation. So we think 200 adults will come. So this will be 200 tickets at X dollars per ticket. And we think that 250 children will come. So 250 children at Y dollars per ticket. And that will give us our total sales. We want to raise $3,800. So that is the equation to represent our ticket sales when we have a desired total ticket sale of $3,800. So that is translating story problems into linear equations in standard form.